Hello, in this video we've got another exam question which is it's dynamics, but it's very similar to our kinematics question. So we have literally just added in the forces on this one. Although initially it's just a straight kinematics question, but we've got forces creeping in at the end. So let's pick our way through this one. We've got a toy car placed at the top of a ramp. The car's released from rest travels 1.08 meters down the ramp in a time of 1.2 seconds. Assume there's no resistance to the motion of the car. Right, so initially we haven't said anything about forces here. They just want us to get the magnitude of the acceleration of the car and then find the speed of the car when it's traveled 1.08 meters down the ramp. So yeah, we can do these in any order. I mean, it's easier to go the other way round on these. So we know that the distance traveled, this 1.08 meters, is the accumulation of the velocity. So that's going to be our 1.08, which has happened in 1.2 seconds. That's going to be our average velocity. So we know that that's going to be the final velocity divided by 2. So that's going to be our v over 2. And that's also going to be equal to the accumulation of the v is the accumulation of the acceleration. So that is going to be equal to 1.2 times a over 2. So this is our collection of things that we have to solve in order to answer the first two parts of the question. So we're coming back to those old kinematic favourites of the distance is the accumulation of velocity and the velocity is the accumulation of the acceleration. So if we solve all of these, we're going to get, what are we going to get? We've got 1.08 divided by 0.6, which is 1.8. You think of how many sixes go into 108, it's 18, so we've got 1.8 there. So v equals 1.8 meters per second. And in order to, we need to divide that by 1.2 in order to get a. So we're multiplying it by 5 over 6. So a is going to be 1.5 meters per second squared. So that was just straight kinematics. We haven't actually done anything else there. The last part, we need to find the angle of the ramp. You can kind of see that that's coming as soon as they tell you we're on a ramp, but they don't tell us anything about the ramp. So we've got a setup, we've got some ramp, we've got some angle. This thing is, chugging its way down. We know what the acceleration is. It's 1.5 meters per second squared. And we've got the only force that's acting down the plane, because our reaction force being perpendicular, the only one that's acting down the slope is the component of the weight, mg. We don't know what m is, but that's fine, because if we use Newton's second law, so for Newton's second law, and then parallel to the slope, we're going to have the mg sine alpha, the component of the weight down the slope, is equal to the mass times the acceleration, 1.5, that is the acceleration, times the mass. And then those are going to cancel. So sine alpha is going to be 1.5 over g. So if I take g to be 9.81 and then do the inverse sine of that, gives an alpha of 8.8 degrees. Yeah, and I think we warrant calling it 8.8 because we do have a 1.08 meters going on there, 1.2 seconds. So we have used forces here. We've done dynamics in the last part. We brought in Newton's second law and we've done dynamics. The first part was just straight kinematics. And hopefully you will then see, and if you've gone through the kinematics section and you're used to this new way of describing things, and we've done these two parts of the question here for 5 marks in nothing really. when you're thinking about the accumulation of quantities. So it's a really nice question to, excuse me, it's a nice question to give that bridge between kinematics and dynamics.